It's said that 350 years ago, white men bought Manhattan from First Nations for the equivalent of about $10 in beads, blankets, maybe a couple of bottles of Gatorade. Okay. Right now, the real estate on Manhattan is worth about, I don't know, I'm going top of my head, 200 billion. Does it sound like they got taken? If they, the First Nations, would have taken that $10 and put it in just a bank account and earned interest on that over the last 350 years, they would have 1 trillion. That's the power of compound interest. Okay? Which is worth more than the real estate on Manhattan. All the skyscrapers, and okay, it's all big multi-billion-dollar companies, right, and stuff. Okay? That's compound interest. Did they do that? No, of course not. Were there even bank accounts back then? I don't know. Okay? So, Mike invests $5,000 in what they call a GIC, a Guaranteed Investment Certificate. In the planning circles, the only part of guarantee is that you're guaranteed to lose money, because usually the rate they pay is less than inflation. After tax, you actually lose purchasing power. Anyway, don't get me started. Okay, he earns 3% per year. What's the growth factor? 3% is 0.03. Again, I don't want to times 5,000 by 3% and then add it to 5,000. What's our trick? Multiply it by 1.03, and then at the end of the year, how much money is he going to have? Times 1.03 is 3% interest, plus the 5,000 he put in, he'll have 5,150. And so on and so on and so on for how many years he does this, right? Write the product which represents the value of the investment after 1 year. Well, I just did that. Do not evaluate at this time. Oh, darn it. I'm too late. Okay? So far, so good? All right. Write a product which represents the value after 2 years. Okay? Well, we would just do this twice, right? 1.03, that was 5,150. And then after another year, I get another 3% growth in my money. Okay? Hopefully it sits there for 350 years, but probably won't. And Mike won't care because he'll be long dead. Okay? After 2 years, that's what we have, right? Everybody good with that? Can I write this a different way? That's 1.03 to the power of what? Okay. After 2 years, it's just like putting a 2 there. Okay? So that's common sense. Now we got to look at the formula. How do I make the formula fit that? Okay? I would have to go take that 1.03. This is n minus 1. So what does n have to be for this to work? 3, right? So if I did this for 10 years, what would I have to do? Well, T10 is what I started with, 1.03. Okay, after 2 years is 2, so after 10 years has got to be 10. Okay, but again, to fudge it, to make this formula work, I'm going to have to do this, right? So what I'm trying to convey here is just like when we're doing years, we need to subtract and add 1. If you see this wording, after, if you want to use the formula and make it work, we have to add 1 to it. Then it will work. If you use the first term. Okay? And I know we're kind of going around in circles here. Let's just backtrack a bit. Okay? Here, remember I didn't use the first term. I used this, the second term, and then I used n was 7. Okay? At the end of the 7th year. Let's go back to my rabbits. If I use the first number, like subtracting years, I had to add 1, right? I had 15 years plus 1. Okay? It will work every time if you do it like that. Okay? Whether you're doing a year question or whether you're doing something that's worded after 2 years, okay? If we add 1 to it, you can use the formula. If you want to make that, well, maybe I shouldn't say this. Okay? You would have to take the second term. You remember this question here that we did yesterday? 3.5 and 3.5. After the first enlargement, if you want to let that be T1, okay, then I would just use this, okay, after 4, okay. But if I want to use the original thing, okay, I would have to go add 1, okay, so it works. So I would go 5 minus 1. That's not the same thing, is it? After 4, I would use here, that's got to be 3. Okay, I'm confusing myself. Okay? Okay? So, it's a way that, if it's confusing, and I find it confusing, okay, every time you see after, okay, we add 1 and that'll be n. So here, n will be 5. Okay, and it'll work. You can use the first number you got. If you're happy you doing it the way with this question that you did before and using that method, okay, that works too. Okay, where was I? Here. All right. So what's the value after 1 year? I knew it was this. I just did that, right? So if you want to use the formula, what does n have to be? 1 plus 1, n is 2, and then you see you have 2 minus 1. Okay? After 10 years, if you like, you can just take that number and stick it right there. But like I'm saying, if we just add 1, we can use the formula. A R n minus 1, it's the same thing. Okay? So let me repeat that. If you're using a question that has 2 dates in years, subtract the years, add 1, that's n. If it says after, okay, or at the end of, take the number that's given, add 1, and that's n. It'll work every time. Well, 2 minus 1 is 1 at the end of 1 year. I just have 1 compounding of that money, right? So n is 2, 1 plus 1 is 2. Here's the formula. Okay?
Wait, for the first year?
After 1 year, I have just 1 compounding. I know it has to be this.
Oh.
Okay? So if that makes sense, do it. But if you want to use the formula, you got to add 1 to it. Okay? Having said that, look at number 9. On the 10th day, what do we do here?
Wait.
How can I make that? Because I said if it says after or at the end of, on the 10th day, can I also say that's after the 9th day? Okay, then I'll take 9 plus 1, okay, n is 10. It's the only sticky little part. If it says at the end of, after, we'll just do this. Add 1 to it, that's what n is, okay? But that one's worded a little differently. All the other questions should be fine.